the charge of protons is equal to that of the charge of electrons. Electrons has a negative charge, protons has a positive charge. That is the only difference. And the charge of the proton is equal to 1.6 into 10 to the power of minus 19 coulombs. We have another particle inside the nucleus that is called as neutron, which has no charge. That is, the charge of neutron is equal to 0. According to Rutherford, an atom consists of very small nucleus surrounded by orbiting electrons. So this was the proposal given by Rutherford. And how to represent the existence of proton in periodic table? They have followed a notation where X represents the element, Z represents the atomic number, A represents the mass number. Z is equal to number of protons and A is equal to protons plus neutrons. So this is the notation they have used to represent the nucleus of an element, which is similar to that of the notation that is used in the periodic table. And if we go further towards neutrons and protons, these are the basic properties of nucleus. The basic properties of nucleus include nuclear size, charge, nuclear mass, nuclear density, nuclear spin, nuclear magnetic dipole moment, nuclear quadrupole moment. These are the basic properties we need to have an idea if we want to study nucleus of a given atom. Nuclear size. Nuclear size depends on the number of protons and neutrons inside a nucleus. So nucleus లోపల ఎన్ని నెంబర్ ఆఫ్ ప్రోటాన్స్ ఉన్నాయి, ఎన్ని నెంబర్ ఆఫ్ న్యూట్రాన్స్ ఉన్నాయి అనే దాని మీద న్యూక్లియస్ యొక్క సైజ్ డిపెండ్ అవుతుంది. అండ్ ది రేడియస్ ఆఫ్ ది న్యూక్లియస్ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు క్యూబ్ రూట్ ఆఫ్ మాస్ నంబర్, and R is equal to R naught into A to the power of 1/3, where R naught is a constant which is equal to 1.2 into 10 to the power of minus 15 meters, where 10 to the power of minus 15 meters is also called as Fermi meters. Nuclear charge. Nuclear charge is always positive due to the existence of protons in it. The charge of the nucleus is only because of protons. Because the charge of neutrons is always 0. Nuclear mass. How to calculate nuclear mass? The nuclear mass is always equal to, we have a formula where Z is atomic number, A is mass number, Z represents number of protons, A represents protons plus neutrons. Kabatti total mass of the nucleus is given by Z into mass of proton plus A minus Z into mass of neutron, nothing but number of neutrons. Nuclear density. Nuclear density is always a constant and it is given by A by 4/3 pi r cube. Nuclear spin. We are all familiar with electron spin from our vector atom model, which says that electron has two spin values, plus half and minus half, representing the clockwise or anti-clockwise rotation. Similar to that of the electron spin, nucleus also has a total spin value because of protons and neutrons. Now ఇక్కడ మనం గుర్తుపెట్టుకోవాల్సిన పాయింట్ ఏంటి అంటే, నాట్ ఓన్లీ protons but also neutrons has spin value. So here also, similar to your electron, the spin of a proton or neutron is always equal to plus half or minus half depending upon its direction of spin. And this is the way of calculating atomic spin magnetic moment, which is a resultant total sum of magnetic moment spin of electron and magnetic moment spin of nucleus in a given atom. Sorry.